Electromagnetic waves and Maxwell's equations. So energy is the measure of the ability of something to do work. There are many forms of energy which can transform from one type of another to another. Potential or stored energy include batteries and water behind a dam. Kinetic energy is the energy that an object has while it is in motion. Charged particles such as electrons and protons create electromagnetic fields when they move. These fields transport a type of energy which is called electromagnetic radiation or light. So a moving charge gives rise to both electric and magnetic fields. The electromagnetic waves are waves that are produced by only accelerating charges, and they consist of oscillating electric and magnetic fields. Oscillating electric and magnetic fields travel away from the accelerating charges to create an EM wave that lasts longer than a pulse. The charges must continue to accelerate. So electric and magnetic field, as shown in this picture, are perpendicular to each other, and they are moving away from moving as a wave. So this is also a very cool picture of an electromagnetic wave transferring. So if it doesn't make any sense to you, just know that these are electric and magnetic fields with propagation vectors. And for this class, I just wanted you to get introduced to this picture. We're not going to do much with it. Another concept that we are not going to do much with is called Maxwell equations, but since you're taking Intro 2, I thought it would be very useful for you to actually appreciate the subtleties and the importance of Maxwell equations. Maxwell modified Ampere's law and then used it with other basic laws of E and M to show that electromagnetic waves exist, and then derive the properties of these electromagnetic waves. So Gauss's law that we did in chapter 16 says if an electric field line is not a closed loop, it can only start and stop on electrical charges. Electrical charges produce electrical fields. Gauss's law for magnetism says magnetic lines are always closed loops since there are no magnetic charges or monopoles. The magnetic flux through a closed surface or the net number of lines leaving the surface is zero. Faraday's law says changing magnetic fields are another source of electric fields. The Ampere-Maxwell law says changing electric field as well as currents are the sources of magnetic field. Magnetic lines are always closed loops, but the loops do not have to surround currents. They surround changing electric fields as well. So this is a definition of all of these laws in English. Now what about what these laws look like when you're talking in physics or in math? This is what these laws look like. The first law, the second law, the third law, the fourth law. Okay? Lucky for us, for this particular course, we are not going to go into details of these experiments. These equations.